Hello, Mass. How you doing today? I hope you are feeling much better with this nice weather. Today we're gonna have some science tricks because I know some of you asked me to do a second part of our science tricks, first video that we did. So today I have a couple of tricks, science tricks, that I know that you will enjoy it. So our first trick is called reverse illusion water tricks. And for this, we're gonna need a glass with water, a note card, and some markers. Okay? So get ready to gather your materials. Okay, so now that you have your materials, we're gonna start with our first trick. For this, I draw this face pointing to the right side. So I'm gonna put it behind the glass full of water and we will see what happens to the face, okay? Ready? Let's go. Gonna put it, do you see it? It's pointing the same direction, right? To the right. Let's see if I move a little bit to the back. What do you see? So it's here, right? Let's see if I move the paper back slowly to the back. What is happening to the face? What is happening? Yeah, do you see that it's pointing to the left, right? That's what it is now, it's pointing to the left, right, and left. Why do you think this is happening? Why do you think just happened? Okay, so think about it and let me know in a little while. So now I have here an arrow. Green arrow pointing to the right again. So we're gonna try the same thing to see what happens with the arrow. Okay, we're gonna put in the back to the, here we see it, back to the glass full of water, and we're gonna move it back a little bit slowly to the back. What is the arrow? Do you see it? Where did it go? Yes. Do you see? I see like two arrows, but I see the head pointing to the opposite side. Try again. Why do you think this is happening? I see it here now. Do you see? I see it here now. So when the arrow is moved to a particular distance behind the glass, it looks like it reversed itself, right? That's what we see. It reversed. The head was pointing to the right, as we see here. But when we move to a particular distance, do you see? It started changing the position, the direction, and I see it here too. So, when light passes from one material to another, it can bend or reflect or refract. Okay? In this experiment that we are doing, light travels from the air through the glass. So, the air, the light that you see travels from the air through the glass, and from the glass through the water, through the back of the glass, and then back through the air. So before hitting the arrow. Anytime the light passes from one medium or material into another, it refracts. So we're gonna see now with this letter E. What happened with the letter E? I see it here. It depends on the position that we are in. Okay. You see, I see here. I see it here. So To explain this, you must think about the glass of water as if it is a magnifying glass. So when light goes through a magnifying glass, the light bends toward the center where the light all comes together is called the focal point. Okay, so it says here. And where it's gonna appear now? See it here. Okay, let's try in a different point to see if it comes better. It depends of the position that you are in. Do you see? It seems like it divides into two pictures. Do you see? So we try to find, so it's here with a long arm. You see, at some point you see invisible. Do you see here? And you see a part coming here, and another seems to come through the back here, and it's a whole paper. Do you see? But you see, as we move back the paper a little bit, you can see even the invisible part. You see? I can see the bottles that are behind the paper here, the vitamins. You see there? But when I move the back, it becoming too invisible. So we are making another experiment now here. You see, we discovered something else. We discovered that it's invisible in the middle, and now the drawing is in the opposite way, facing the left, while here is invisible. So we make a good discovery. So it is called focal point. The image appears to reverse because the light rays that were bent past each other, and the light that was on the right side is now on the left side. Okay? And the left on the right, which makes the arrow appears to be reversed, and the same with our pictures. That's why it appeared to be reversed. Okay? Because the light and the focal point. So let's see with this one. You see? This one. And let's see what happens now. Where is she gonna come? And again, we see our invisible. And how about if we move the bottle here? We can try different position to see which works better. Okay, so now I see her here. Do you see? See her here. And now she comes back. And now, how about if we move the paper more here? Let's see what happens. Because we are experimenting. Okay? Oh, you see? So now she's there with a long hair. Do you see this? So I put her here. She's pointing to this side to the right. But when I move the paper back, she unites into one. And you see this? Wow, it's incredible. We are making art too. You see? Yeah. You see how it looks like the colors are spreading all over the papers. And now we have 3. Do you see this? We have 1 here, 2, and 3 women. Oh, incredible. This is incredible. So I hope you have liked this first trick. And now we are going to proceed with our next science trick. So now I want to review for the last time our last trick. Okay, so now it's here. I move it back, and do you see where it went? Right to the opposite side. So let's see this one. She's here. Do you see her? Right? You see? This is the picture. She's here, and I'm gonna move back the paper, and she's gonna be in the other side. Okay. Okay. Here she's in the other side. Do you see her? See now here? She's here, pointing to the right, and now she's pointing to the left. Here. And this is tricky. This is why we call it tricky. And now I see her on the other side. Tricky science, because you need to make tricks to figure it out, right? Okay, with a big hair. She's looking to the other side with a big head. Okay, so let's see this one, the arrow again. Let's see the arrow again, okay, and now it's pointed to the other side. You see? Here and there, okay? Now it looks better now because I put it more in the back. Let's see this. See the letter A, the letter E, and now it's in the other side. So I want you to try yourself at home with different words and drawing and experiment with it. I read here one, and now if I move it, I read. What do you read? Okay. One. Do you read now? Okay, it's a little tricky this one. Now I see the N, O, a big O, and the W. Now, I want you to try with different drawings and different words to see what happens. Okay, and let me know in the comments. Okay, I see in the opposite side now, and let me know in the comments how it looked and how did it work for you. So now we're gonna have our second part, that is our second trick, that is called invisible bottle. For this, we're gonna need a drinking or a glass like this, or another type of glass that we can see through. And we're gonna need glycerin, 6 ounces. I have here this one glycerin bottle that we're gonna need, and we're gonna need an empty bottle, smaller than the other. So now we are going to fill empty bottle with glycerin. We're gonna open our glycerin. We're gonna fill empty bottle with glycerin, but before this, I want us to try first with water to see and to compare. Okay, I'm gonna fill this with water. So I'm gonna put it here so it doesn't float. I want it to sink. I wanna put inside this one. And if you see that it's a lot of water, it's good that you have another recipient like this for you to pour water, okay? And if you need to clean the table, so you're gonna need paper towel or napkins, okay, to keep the space clear. So now, I'm gonna put this here. I'm gonna put inside. And I want you to tell me if you see it. I want you to tell me if you see the bottle inside the other one. Do you see it? Okay, I'm cleaning a little bit here for us to proceed. Yes, I see the bottle here. Yes, I see it. I can see that there is a bottle inside the other bottle, and if I put this I can see too through. I can see through the bottle too. So now I'm gonna take it out. And if you have a smaller one, it's better, okay? Because we are working with what we have, right? So now I'm drying the space. Okay, so we can continue. And now the glycerin, you might have it at home because the glycerin is a liquid. The glycerin is a liquid that is sold at most drugstore for a skin as a skin softener and protectant. So it is used to be made out of animal fats and was typically recovered as a byproduct of soap. Okay, but today it's normally made out of palm kernel oil. Okay, so now that you have this, your materials, I'm gonna empty my glass of water because now I need to pour the glycerin, right? So I'm gonna pour as much as I can because you know I need to put the other one here. Okay, doesn't have to be all. Okay, I'm gonna see here. So now I'm gonna fill both of them with glycerin. This one, okay, and this one. I'm gonna put glycerin. Let's see what will happen, okay? Okay, our eyes are able to see the bottle inside the glass. When we had the water, we were able to see the bottle inside the glass because our eyes can perceive that the light is traveling at a different speed and angle at each of the 4 intersections of glass and water. This distorts the image of the pencil behind the glass, and that's what we saw. But when we put fill the bottle and glass with glycerin, which was what I just did, it looks like the mini bottle isn't even there. That's what we're gonna see, if it's true. We're gonna see if the mini bottle doesn't look like to be there. Okay, and we're gonna see the pencil or the marker behind the glass setup isn't distorted at all. Okay. Do you see it disappearing? The glass? Let me know any change that you see. So I see some bubbles here. And do you see the glass over here? It looks like that is disappeared. Over here I see, oh, it looks like it disappeared, the bottle. Let's try with the marker. You see, we just can see the marker behind the bottle. But it looks like this bottle, the mini bottle, disappeared. You see? And we just see, what do you see? We just see the glycerin here. Remember that the mini bottle has the glycerin that we pour in, but we can see the edge of the mini bottle. So, do you see that the mini bottle disappear inside the big one? Yes? So, okay. I need you to leave your comments under this video and let us know why do you think it's happening. Okay? So, but I'm gonna give you a hint. the small glass looks like disappeared because light travels through glass and glycerin at the same speed, so our eyes don't see a boundary where the bottle is, rendering it invisible. And I explained to you what the glycerin is already, right? That is a liquid that we usually use it for as a soap, okay? As a skin softener and protectant. So if you like this trick, I would like you to leave your comment and try to do it at home. And let us know how it went. Welcome back, Matt. So here I'm showing you again the last one that we did, the invisible bottle, but you see I changed it and I used a bigger container and put the smaller one inside because I want to see the difference. And now I see it more clearly. Do you see? So I see now more clear the invisible bottle, and we're gonna see again with our marker. So you see? We see here and we don't see it here. So now that we check again our last experiment, we're gonna do our last experiment, and for this we're gonna use, it's called Magic Water Barrier. So with this experiment, barrier, Magic Water Barrier. With this experiment, we will learn about the difference in density between hot and cold water and the natural flow of warmer or cooler water. So for this, we're gonna need hot water. For this, you're gonna need the assistance or your help of your parents. We're gonna need cold water, which I put it in the fridge for 15 minutes. Our second cup, so we're gonna put our hot water, which is this. And we're gonna need to like a index card, or I'm gonna use this for your foil, tin foil. And we're gonna need a pan like this, where we're gonna put our cold water. Okay, so now we're gonna need two different colors of food coloring. So for the cold water, so we make a distinction which is which. So I'm gonna use green food coloring for the cold water. Okay, so here to make it clear that it's green, and for our hot water, which I'm gonna pour here now, and I'm using this pen so we don't do any mess. We're gonna use red or orange food coloring. So now, this is a step out. This is what I'm gonna. Okay, so now that we have our cold water for 15 minutes in the fridge, and we heat up a full cup of water. So, and we already mix the hot water with a few drops of red food coloring and the cold water with green food coloring. What we're gonna do now is that we're gonna hold the index card or this. Tin foil. Foil, Angelo, your arm. And but not try because we need to. Okay, so Angelo wrap it up with foil, tin foil, right? And what we're gonna proceed to do now is that we're gonna quickly. We need to do this quick. We're gonna
flip this onto this.
Flip, right? Flip up the hot water into on top of the cold water. And carefully, Angelo is trying to remove. But we need to remove, Angelo. Remove it. But it needs to be the same size. Okay, leave it there, Angelo. Okay, what do we see? Okay, yes, part of the hot water came into the cold water, but anyway, we see that still is the difference between the green and the red.
It's not mixing.
Yeah, why do you think it's not mixing?
I think because hot and cold are different temperatures, so it doesn't want to mix together.
Okay, different temperature water has different density. The normal density of water is 62.4 pounds per cubic foot. Warmer water is less dense. Warmer, which is the red, is less dense than the green one. That is the cold, right? So the warmer water is less dense and will have a lower weight per cubic foot of space. Colder water, the green one, is more dense and will weigh more for each cubic foot of space, and that is why, as it has more weight, it's down under, right? In the bottom. But the hot water is less dense, and that is why it is on top of the green cold water. So I hope you have enjoyed this science tricks. Let me know your comments if you do it, how it went, how it worked. And here we have our two experiments, our invisible bottle and our magic water barrier. So give us some comments, give us some ideas on what would you like to see, and let us know which of these tricks you are going to do. So have fun, take care, keep healthy, and see you next time.
Bye.
Bye.